Welcome to Create Graphs and Equations of Higher Degree Polynomials. The best way to use this video is to take notes while I'm teaching, pausing whenever you need to get the notes down. And every time we arrive at a U-try, pause the problem, attempt it, and then press play to see the solution and the work. These are the topics we'll cover in this section. Higher degree polynomials have the following form. They can look like factored form or general form. We're going to be sketching graphs given factored form of functions. At this point, you need to be familiar with higher degree polynomial characteristics, so if you haven't watched that video yet, please go back and watch that video. We're going to sketch the graph here. So how we're going to do this is we're going to use the zeros and the behavior at the zeros as well, so we're going to use the zeros, and we're going to use the end behavior to help us graph this function. So we've got our zeros. We've got x equals 0, we've got x equals -1, x equals 1, and x equals 5. We're going to talk about what happens at the 0. So that's got a degree of 1, so that's odd, so it's going to cross. This has a degree of 2, which is even, so it's going to bounce. This has a degree of 4, so it's going to bounce. And this has a multiplicity of 3, which is going to make it cross. If you aren't sure how I got those answers, go back to higher degree polynomial characteristics videos for a recap. And then now we know what happens at each 0, let's talk about the end behavior. So we need to find the degree of this function. So the degree is going to be 1 plus 2 plus 4 plus 3. So the degree is 10. And the leading coefficient here is positive. So we know that the end behavior is going to look like this. All right, so here's what we're going to do next. We're going to label the end behavior, and we're going to label our zeros. So we've got a 0 here, we've got a 0 here, and a 0 here, and a 0 there. And we're also going to label what's happening at those zeros. So at -1, it's going to bounce. At 0, it's going to cross. And at 1, it's going to bounce. And at 5, it's going to cross. All right, so where do we start? We start here. So we're going to start here. We're going to go to our first 0 and we're going to bounce it. Now, I don't know how high it's going to get, but I do know that it's going to need to come back down to cross through this 0. And I don't know how low this is going to get, but I know it's got to come back up to bounce here. And I know this one's got to cross so that it can get back to its end behavior, and it's going to look something like that. Let's take a look at what actually happened when I graphed it in Desmos. Pretty close, but not perfect. We'll try another one together. Sketch the graph. So we need our zeros and our end behavior. So we'll start with our zeros. We've got x equals -4 and x equals 2. The multiplicity here is odd, so it's going to cross. The multiplicity here is even, so it's going to bounce. And the degree of this function is 3 plus 2, so it's 5. It's odd, and the leading coefficient is positive. So we know that it's going to look like this. So I'll start with my end behavior. And I'm going to graph my zeros. I've got a -4 and a +2. And this is going to cross, and this is going to bounce. All right, so starting with our end behavior here, we're going to come up, we're going to cross, we're going to come down, we're going to bounce, and it might look something like that. I graphed this in Desmos, pretty similar, and you are going to try these two. Let's see how you did. It might look something like that. It's not going to match exactly right. Now we're going to talk about non-real zeros. Complex zeros, those imaginary zeros that come in pairs. So the problem with trying to write an equation when we're given a graph is we have no idea how many imaginary zeros there are, or non-real zeros, because we can't see things that are imaginary. So when we're determining equations from graphs, we are not able to determine the exact degree. It's just not possible because of those non-real zeros. We can get an idea from the number of real zeros and turning points. Remember, it can have at most degree -1 turning points. And we're also unable to determine the exact multiplicity of that 0. We can only determine if it's even or odd. How can we determine that? Because it bounces at even and it crosses at odd. So it says to write an equation that might have the graph shown. So we want to take a look at the end behavior to determine the degree and the leading coefficient, and we also want to take a look at the number of turning points to figure out the maximum degree. So we've got end behavior going up and up, so we know it's going to be an even degree, leading coefficient positive. Let's take a look at the zeros. The turning points. We've got a turning point here, so that's 1. There's a turning point up here somewhere, that's 2, 3, 4, 5. Nope, not that one. Undo that one. 4, 5. There's got to be one down there. And so there are 5 turning points. So what that means is the degree needs to be 6 or higher. So we'll just keep that in mind. All right, so now we're going to go through and label our zeros. So some of these are already labeled. This guy gets labeled and so does this. We're just going to label if they're crossing or bouncing. So that's a bounce. At -1, that's a bounce. At 0, that's a cross. And at 2, that's a cross. And so we're going to start to build this function out. So we'll write f of x equals, and we'll start with this first one. So if the 0 is -3, the factor is going to be +3. And if it's bouncing, the multiplicity has to be even. Next, we've got a 0 of -1, so the factor is +1. And it's bouncing, so it's got to be even multiplicity. We've got a 0 of 0, so that's just going to be x. It's crossing, so it's got to be odd. And we've got a 0 of 2, so it's x minus 2. It's crossing, so that's odd. Now, you can make these numbers in here any number you want. Even could be 2, 4, 6. We just need to make sure that the degree ends up being 6 or higher, and that it's an even degree. So we've got f of x equals. Now we normally put this one first, so we're going to do x, and maybe you want it to be to the 3rd power. So that guy's gone. Then we'll go in order, x plus 3, even, so maybe 2, x plus 1, even, maybe 4, and last one, x minus 2 is odd, maybe 3. Just do a quick check. The degree here is going to be 3 plus 2 plus 4 plus 3. So we've got 5 plus 7, it's going to be 12. It's even and it's greater than 6, so this is a possible function. Let's do one more. Write an equation that might have this graph. So we see our end behavior here. It's got to be even. Our leading coefficient needs to be positive because they're both going up. And now let's check our turning points. So we've got 1, definitely there's got to be 1 down there. And then 2. Somehow it's got to come back up, right? 3. So we've got 3 turning points. So our degree needs to be 4 or bigger. All right, so now we're going to go through and label our zeros. So we've got -2, that's a cross. We've got 0, that's a bounce. And we've got 4, that's a cross. So now we'll write a potential function. So let's see, we've got f of x equals x, the 0 is -2, so the factor is +2, cross means odd. We've got a 0 of 0, so it's just x, bounce means even. We've got a 0 of 4, so the factor is x minus 4, cross means odd. And now we'll just go through and pick our numbers. Normally we put this guy first, so f of x equals maybe x to the 4th. Now you know you're getting your degree 4 or higher. X plus 2, maybe you leave it alone to the 1st power, and then x minus 4, maybe say to the 3rd power. Just double check. Your degree is 4 plus 1 plus 3. That's 8. It's even, and it's bigger than 4. And that could be a potential function. You're going to give these two a try and see how you did. That concludes creating graphs and equations of higher degree polynomials.